Okay. Good afternoon, and thank you, Arturo, for the nice introduction. I'm really actually delighted to be here with you in Madrid. I'm not in Slices, but I'm a committed member of Fivetonic. We see the value, the significant value actually of experimental research. We have been with Fivetonic for, I think, from the very start of it. And as Juan Carlos said at the start in his presentation of Fivetonic, we see the complementarity between Slices and Fivetonic. So congratulations on the Slices project, and we look forward to that collaboration, Slices and Fivetonic. So York, I think, made my life a little bit easier in introducing this exciting capability that's called integrated sensing and communication. Right? I forgot my mobile phone there. I wanted to kind of just put in perspective actually that capability to you. So imagine your phone being a radar. And imagine the network being a radar. By radar, I mean like scanning you, able to identify you, what activities are you doing and the likes. Not just localizing you and knowing where exactly you are, your coordinates, but knowing much, much, much more about you and the surroundings and your surroundings. Well, that's ISAC, what's meant to do. And that's a little bit scary. Pretty much like artificial intelligence, actually. It's a bit scary, right? So hopefully that gives some perspective about this capability that I'm going to be introducing next. Right, so let me start with that very nice diagram. It wasn't me actually who put this diagram. So this diagram is a product of, the international community involved into this ITUR, the International Telecom Union Radio Communication Sector, right? Putting a common vision on what is going to be actually 6G, right? So you see at the heart of this, I don't know if the laser works here, maybe not, but you see at the very heart, there is a very nice triangle that all of us who have been involved in 5G are pretty much familiar with. So it has the 3 vertices of the EMBB, enhanced mobile broadband, URLLC, and massive MTC, right? So, and these are, envisaged to continue with us and just extend. That's why you see actually these EMBB becoming immersive communication. So EMBB plus, if you like, massive MTC, so massive communication, and hyper reliable and low latency communication. So these are what we are used to as traditional in 5G and IMT 2020. And these are going to continue to be with us, right? And we push the boundaries of these user scenarios in 6G. Now, what's interesting actually is that the global community, the international community, they've already actually agreed upon 3 additional usage scenarios, right? One that is to a certain extent conventional, that's on satellite, the integration of satellite with terrestrial. So that's what actually the ubiquitous connectivity vertex that's showing on that hexagon. But there are 2 that are fundamentally unconventional. First is the integration of artificial intelligence into the system. So this is the blue dot on the right-hand side. And the other one actually is the integration of sensing with the communication, right? So this ISAC, when we refer to this ISAC, so there's already global international agreement that this is going to be a capability, a very important capability like AI, right, that need to be integrated into the 6G system. And one key point here actually here is that, we've already seen, I think, a device from Carlos. Okay, 1 second. Just for the laser. Yeah, thanks, Arturo. I now have to juggle between the 2, but that's all right. Yeah, so sensing has already been with us. Right? I mean, you've seen that device that's doing some sensing. Same with AI. AI, anyway, it's already part of the network, and I think the colleagues from Telefonica, can witness that or evidence that. So here, the challenge really is on having these capability integrated into the system. So really, the challenge here is on the integration bit, right? How do we have it integrated into the system from day 1 when we design it? So that's setting the scene a bit, I think I've already put that capability into perspective. Think about the radar. So this is a new capability that we are adding, to the network, to the system. And basically, we are using the radio signal, right, to do some sensing of objects. Now, these objects can be actually connected or not connected to the network, right? And so what kind of scenarios we are talking about here, like detection, estimation, localization, tracking, navigation, monitoring, imaging, all these kind of user scenarios that would benefit from that capability. So what do we do with that sensing data that we are collecting inherently now from within the network, right? We use it to optimize the performance of the network, right? So the network becomes more agile and more adapted based on that data that we are collecting and the analytics that we can derive out of it. And second is actually also we optimize the services that are running on top of the network, right? So these are like the two key, if you like, usages of that data that's collected. So in terms of use cases, there are so many use cases that are already being identified actually that benefit from that capability of ISAC. So I just put in actually a summary here. So there has been a recent study in the 3GPP project, the third generation partnership project. So the global SDO defining, 5G and next 6G. So they came up with 32 use cases already, right? That I tried to categorize here a little bit, in five categories around object intruder detection, collisions avoidance and trajectory tracking, automotive maneuvering and navigation, monitoring both environment, health, sports activities, and provisioning of sensing, especially for applications like immersive reality or extreme reality like XR, but also digital twinning as well, right? And of course, that new capability, which is totally new, it's unconventional, right? To be able to introduce that capability in the system, we need some metrics to measure it, to evaluate it, right, to verify it and the likes. And that's what actually the ITU, again, ITU refers to International Telecommunication Union. So that's what the ITU now is doing in terms of figuring out what are these performance metrics, right, for adding that capability of ISAC, and what would be the requirements. So what would the 6G need to meet as requirements for that capability and how we measure it. So we expect actually this to be concluded hopefully the next couple of years when the INT 2030 is going to actually release the requirements for 6G. All right, so I think Jörg already helped me out here by introducing or touching upon the monostatic and the bistatic, right? So this is just really a basic kind of introduction for these. So again, keep in mind that we are talking about the device or the network, the base station being a radar, right? So here we have two modes. We have the mode what we call monostatic sensing. So me, the transmitter, transmitting and receiving, right? So that's what we refer to as monostatic. And then of course you can imagine multiple nodes in monostatic mode distributed, right? And they collaborate together to kind of, do that sensing task coordinately and jointly. So what's interesting here is that because the transmitter and the receiver, they are the same device. So there's no issue or challenge around time synchronicity, right? So as by default is given. There is a requirement for full duplexing, pretty much like Jörg already introduced. So because we need, we are transmitting, we need to be receiving the echo of the target that we are actually sensing at the same time, right? Now, it happens that most likely the reflected, signals from the echoes are going to come from a different direction, right? So naturally, we'll have some form of self or interference cancellation, but still, I think there is a push to try to get that fully proven full duplexing capability to enable that monostatic sensing mode, right? And then, of course, if we try to do it with multiple nodes in a monostatic mode, coordinating together, then, of course, then we have that time synchronization requirement now across the nodes, because they need to collaborate together in a timely manner to be able to make some sense out of all these reflected signals that are processed by these different nodes, right? So this is monostatic sensing, and this is the distributed multi-node monostatic sensing. So these are two, if you like, big sensing types that we are considering. And the other one is referred to as bistatic sensing, right? Or even multistatic sensing. So basically here, the transmitter and the receiver are separate nodes. So I do transmit, Then the signal hits a target. The target reflects. Another node would be the node receiving the echo reflected by the target. And that other node will be doing the processing, right? So we refer to this as bistatic sensing. And now here, certainly, there has to be some time synchronization between the transmitter and the receiver to be able to do this sensing task in a proper way, right? And then, of course, if we extend to multiple nodes receiving the echoes and coordinating together, then there is also time synchronization requirement across the nodes as well here. And there has to be some element of, an engine doing that fusion of all this sensing result coming from different nodes. So there is a central fusion requirement that comes out with the sensing type, right? And of course, we can have this hybrid of monostatic and multistatic coming together, right? So that adds complexity, significant complexity further, time synchronization, fusion side, and the likes. So I really wanted to keep it really high level. But really the main takeaway is that this sensing capability is transforming the network and the device into kind of like radar, with the wide plethora of radar usage scenarios and the likes with this. So now next, just to introduce a bit actually what's going on this capability in terms of research. There are a lot of projects, and fortunately for us here in Europe, many European Union funded projects that are addressing actually that capability of ISAC. So many in that 6G SNS program, like 6G Shine, 6G XR, Centric. There is research infrastructure project that we have with Surge called Converge, HexaX, Island, Times, really a number of these projects. There are also projects funded by the German government, BMBF. There are in the UK, and forgive me, Arturo, I missed to add the UNICO projects in Spain that are addressing, but I'm totally aware that there are projects here in Spain that are addressing that topic, right? Now that's on the research side. And so we are spending or investing a lot of millions of euros with the whole community here in Europe, but not just in Europe, right, on this capability, right? So, and this capability is already being picked up on by pre-standard and standard bodies, global standard bodies, like, as I said, ITU IMT 2030 is already identified and agreed that this is a capability that needs to be added in. The 3GPP, the most important body, right, defining what 6G is going to be, they already agreed that this capability is part of the study that the 3GPP is going to do for the release 19, which is in the next 18 months, to prepare the ground for the 6G, right? Also in IEEE and WLAN, there has already been some work on WLAN sensing. How do I do sensing with the WLAN protocol? But not only in WLAN, also in ultra-wideband, 802.15, right? And what I wanted also to bring to the attention to you here actually is a new group that I had actually the honor to lead at ETSI. ETSI is the European Telecommunications Standard Institute, on that technology of ISAC, right? So we created recently an industry specification group focused on this specific technology of ISAC. And the idea of this ISG is really bridge all this fantastic research that's happening in Europe with the European Union funds, right, and the national funds of the countries in Europe, to bridge this fantastic research to high entry barrier standard bodies like 3GPP through ETSI. So we prepare actually, so all this research that's happening on this, we try to channel it in a proper framework of standardization at ETSI and prepare it to go into 3GPP to make the most impact possible, out of this research, right? So this is really the idea of this ISG. And just to say that this technology is not just concepts on papers, and as Jörg already actually presented, right? There are already prototypes, and I would love Jörg to add your prototype to the list of prototypes that are listed here, right? So we have from HexaX, from Huawei, multiple demos at Mobile World Congress 2023, Qualcomm, UCLZT, and then the one that was presented by Jörg earlier. So we are doing experimental research already on this capability. Yeah, so this is, if you like, a snapshot of that ISG. ISG stands for Industry Specification Group at ETSI, right? So we got this approved at the board meeting by the ETSI Director General on the 19th of September. So this is still very fresh, as we say. And we plan the kickoff for this meeting, for this ISG on the 17th of November for the first 2 years. So we co-funded this initiative with 22 ETSI members, right? So the list of the members is on left-hand side from my side, the right-hand side on your end. So we've got, Interdigital, we got Apple, we got Samsung, we got NEC, we got, Telenor, we got supporting companies like AT&T, BT, Orange, right? So it's quite significant. And I have no doubt that, the colleagues from Telefonica have also an interest. I've been talking to Juan Carlos earlier, and also India and UC3M are going to be joining us. So basically, I expect this group really to go, to grow significantly with many companies and universities and research institutes. So it is open to new members to join in. Following, that's a protocol at ETSI, what we call the issue of the collective letter that's due by mid-October this month, right? And I've had, as I said, I was leading that one. Again, I think I already touched upon the mission. So really the mission of this ISG is to coordinate the pre-standard research effort on ISAC, right? Especially, from the European and national funded projects, right? And try to pave the way for 6G standardization of the technology, right? So what's going to be the output is pretty much like what we call group reports and proof of concepts and prototypes on prioritized 6G use cases, sensing types, channel models, architectures, and deployment considerations. And the aim here is not to interfere with 3GPP, but to complement 3GPP by having information ready for 3GPP to pick up on from the release 20 onwards for 6G. So this is the whole idea. And that's just a snapshot of the scope that was agreed by the funding members. So as I said, 6G use cases, sensing types, channel models. And here I think would like to draw an attention to the experimental research that's required, because really to be able to get that capability, designed properly, right, and the whole community agreeing upon it, we need what we call channel models. And to get these channel models, we need extensive measurement campaigns. These campaigns cannot be done by one member alone. So they require really extensive experimental infrastructure to do these kind of, measurement campaigns. So we address, evaluation methodologies, system run architecture, but we also touch upon the privacy and the security aspects. As I started, yes, it is a bit scary. So we need to look at these privacy security aspects, but also there also may be an impact on energy efficiency, sustainability goals. So that's also being part of the scope of this ISG. Yeah, I think I've already touched on that one. So this is just a snapshot of the timeline and the deliverables for that ISG. Right, so to conclude, I hope I'm still within the time. So ISAC is obviously a very important capability, pretty much like AI. And that's agreed by the whole stakeholders in telecom for 6G. So the design assumptions, so this is really critical. The design assumptions for ISAC, they are not established yet. They need to be established. And for these to be established, we need the support of research infrastructures, definitely, like slices, like 5tonic, like others. And that's, I think, what I conclude with. So thank you very much for your attention. Hopefully you found it insightful.